What's going on, everyone? Welcome back. Patrick here, and in this video going to do another trig limit. So we got the limit as x approaches 2 of sine of 2 minus x over x squared minus 4. So this is a unique trig limit that we haven't covered yet, but like in the previous examples, which I'm assuming you've watched before watching this one, I'm going to be using these results if I have to help me out in the process. So notice here we can't make a direct substitution because if we plug in 2 for this x and then 2 for this x, we're going to end up with 0 over 0. And it actually doesn't matter if we get a 0 in the numerator as much. If the denominator is 0, can't be dividing anything by 0. It's going to be undefined. So what we got to do is some kind of other strategy, and more specifically in this case, what I'm going to do is I'm actually going to factor the denominator. Notice x squared minus 4, that's a difference of squares, where we'll have x minus 2, x plus 2, like that. Now, for the previous examples, what we've been doing is lots of times we'll have sine of an expression up here in the numerator, and what we want to try to get is that same expression in the denominator, because then if we have that, then we can do a change of variable and put it into this format, as long as when x is approaching whatever value, that expression is going to be approaching 0. So we can make that change of variable where theta is going to be approaching 0. I mentioned that in the previous example. So notice here we have sine of this expression 2 minus x. So we need that same expression in the denominator. Notice we're really close. We got this x minus 2, but it's not quite the same as 2 minus x. But we can make it the same by doing what? We can actually factor out a negative from this bracket. And remember, if we have x minus 2 and we take out a negative, then all these signs are going to change. And so that's just going to end up being negative 2 minus x. And then notice that it's going to be the same expression there. So we could take out a negative from this bracket, 2 minus x. Now when we take out a negative, we're only taking it out of this bracket. Because these are multiplying, we don't take it out of this bracket as well. So this bracket actually stays the same as x plus 2. So just factor out a negative from this bracket, and now we got that. Now what I'm going to do is I'm going to use a couple of limit laws. So number one, there's like a negative 1 here. I'm going to factor that out of the whole limit. That's just a constant. So I'm going to take the negative out, and we'll have the limit as x approaches 2. All right, it's like a negative 1 in front. And then what I'm going to do is I'm going to take sine 2 minus x and just put it over this factor here, 2 minus x. But then we have this x plus 2 remaining in the denominator, so I'm going to create a separate expression for that. So I kind of took this, split it up into 2 expressions that are multiplying by each other, and they're still part of this overall limit here. And then from here, still got the negative outside, got the limit as x approaches 2. What I'm going to do is I'm going to use the limit law where when we're multiplying 2 functions here inside a limit, we could create 2 separate limits that are going to be multiplying by each other. So I'm going to say the limit as x approaches 2 of sine 2 minus x over 2 minus x times the, kind of running out of space here, these are going to be multiplying, so the limit as x approaches 2 of 1 over x plus 2. Right? Negative, this bracket, they're all just multiplying by each other in one line. So notice here, this limit, I'm going to work with separately for now on the side, so I'll have sine of 2 minus x, and then I'll have 2 minus x. Notice we could do a change of variable because we can say theta equals 2 minus x. And notice that as x approaches 2 here, which is what the limit is based on, as x is approaching 2 here, when theta is equal to 2 minus x, notice that theta is going to be approaching 0. Which, when we do that change of variable to get into this format, we want that happening every time here. And notice it is going to be happening. As x is approaching 2 in this expression, theta equals 2 minus x, the theta is going to be approaching 0. So for this, we could sub in this, and then for these two expressions, we could sub in this expression. So we'll end up with limit as theta approaches 0 of sine of theta over theta. What does that end up equaling? That ends up equaling 1, using that fundamental limit property, trig limit property. Right, so that this bracket here just ends up equaling 1 with this work. So let's erase this for now. Notice we'll have this negative, it's like a negative 1, times 1, which is this bracket. And then notice here, we don't have to do anything but a direct substitution, because if we sub in 2 for x, the denominator isn't going to be 0. So we could just do a direct substitution here. We would end up with 1 over 2 plus 2 is 4. So negative 1 times 1 times 1 over 4 gives us negative 1 over 4. And so that ends up being the answer for this right here. Right? So you may run into questions like this where you have to factor. And this could be anything, doesn't have to be x squared minus 4, as long as like this factor is going to be the same as this factor. And sometimes, again, you're going to have to factor out a negative to make it the same. But we could have had any factor here. This could have factored to like x plus 3, let's say, or x plus 5, or even just an x by itself. So this could have been any polynomial, right? But when you factor it, usually there's going to be an expression in that factored polynomial where this expression is going to be part of that factoring. But for this specifically, answer ends up being negative 1 over